Hello everyone, this continues on with a quick brief on APIs. The learning objectives for this part of the lecture are being able to describe two types of APIs at least and data interchange formats. I'll note that this is not going to be a deep dive into APIs and web programming. It's out of the scope for the class. Really what this part of the lecture is about is to get you, if you're not already familiar, get you at least familiar enough with the language of data of web programming and APIs to be able to do essentially the Module 1 assignment and connect to some web service to collect data and do some analytics. So really what we're talking about, as I mentioned, is APIs and how they sort of fit between the data mining aspect of this class and the web scale data sets aspect of this class. So the motivating question for this part of the lecture, or this particular segment, is really about how we get data from the web. Now there are two main methods that we can talk about. The one of primary interest is the use of APIs, but there's also web scraping. So I'll talk briefly about web scraping first, but I'll note that web scraping is generally the less preferred thing for us to use. So some advantages of web scraping as opposed to APIs. For web scraping, essentially, if you can view the data on the web, you can scrape it in some very coarse kind of way. So that means that if it's there, you can view it in your browser, you can collect it. And this is able to be done without without any API, which means you're generally less limited by rate limits or necessary authentication. Though there's some gray area where if you have to log into the web page in order to view the data, then you may have to deal with authentication there. But there's a lot of work around being able to develop plugins for browsers that let you scrape data from Facebook, these kinds of things. But there are significant disadvantages with this approach. First, when you're using web scraping, you end up with relatively messy and unstructured data. So with APIs, you generally end up with at least some semi-structured kind of data, or maybe you're doing direct kind of queries onto a database and you can get data out in a very, very clear format. With scraping, you have to deal with parsing HTML or parsing text or parsing XML, which ends up being pretty cumbersome. In addition, web scraping also tends to be very brittle, meaning that since you may have to parse HTML content in order to extract the particular pieces of the data that you care about, a slight UI change or a change to the way that information is presented could break everything in your scraper, depending on how your scraper is working. And then, because you don't have to deal with API rate limits or authentication, it's possible and not very hard to overload servers. A lot of servers have, or a lot of web services rather, have things in place to prevent massive hammering on a server. So you can write code that scrapes a web page and basically hammers away, sending up many requests to that page or many requests to that server. Overload the server and then have your IP banned from accessing that server. As an example of this, Stack Overflow has an API, but their API is not very complete with a lot of data that the platform has. For instance, there's a section in Stack Overflow called Developer Stories that contain a lot of information about cross-platform alignment for Stack Overflow users, namely their name, if they have a Twitter account or a GitHub repo or a website, what communities or exchanges they're involved in, these kinds of things. There's a lot of value in the developer page, but you can't access it via the API, but you can scrape it. Scraping it can be slow because if you try and hammer away on Stack Overflow servers, then they ban you pretty quickly and you end up getting errors back, and it may be hard to identify when those errors happen. So there are significant disadvantages to using web scraping. But there are definitely tools for it. So there's the Scrapey tool, which is pretty popular. There's Beautiful Soup, which is used very often because it helps you parse HTML from web pages. There's Selenium that allows you to do browser automation, which is actually very useful if you're doing testing for web services kinds of things. But when we talk about getting data from the web, really you should use an API if that API is available. Only rely on scraping if you can't use the API for whatever reason. And there are legitimate purposes for that if you're doing research where maybe there just isn't an API, or the API doesn't allow you to access the kinds of things you want. There's a pretty famous or well-known issue right now where Facebook has a lot of, or used to have a lot of political ads on the platform, and ProPublica developed a plugin for people's browsers where they could go to Facebook, and this plugin would essentially parse your Facebook feed to look for these ads and then ask you whether they were political ads or not. ProPublica then released the data for that plugin to a university, and the university started developing a data set and asked for volunteers to provide their information or install this browser plugin. Rather, it was this essentially a scraper. And then Facebook sent that university a cease and desist letter. And now there's a legal issue about, well, who owns the data that's on your screen, these kinds of questions. So there are legitimate reasons to use scraping, but it introduces a lot of complexity and brittleness that you should probably try and avoid if you can. So use an API if it's available to you. All right, so what is an API? So API stands for Application Programming Interface. For our purposes, we're talking about web APIs. So these are APIs that provide access to some sort of web service. They're available via the web. And this can be used very loosely. They could be a program that's just running on some random port on some remote server somewhere. There are protocols and structures around APIs that we'll talk about. So there is an older style of APIs called SOAP APIs. We'll talk about that in a minute. The more recent kind of APIs that you'll encounter a lot more are what are called RESTful APIs. And as I mentioned, you can really have any sort of interface that's exposed via the web that allows for programmatic access, essentially counts as a web API. We won't talk about anything really besides SOAP and RESTful APIs. And SOAP APIs, I'll just tell you about, so if you come across them, you're familiar enough with them, because they're primarily more legacy kind of access. So SOAP stands for Simple Object Access Protocol. It's primarily based in XML and the extensible markup language. Most SOAP APIs now are run over HTTP. In fact, many web services are run over HTTP. I'll talk about that, or about why that is, in a minute. But these are generally legacy things. You don't see these so much anymore unless somebody's running some heavy Microsoft kind of shop. Now, most APIs on the web are these RESTful APIs. REST means, or stands for Representational State Transfer. You don't really have to worry about that or like why that's the case, but they're primarily JSON based. So I'll talk about the difference between JSON and XML in a minute. JSON is a very popular data interchange format, and RESTful APIs are designed to operate or work on top of HTTP. So I showed you in the previous slide, SOAP can work on top of HTTP, but it's not. It doesn't have to. RESTful APIs in general are meant to operate on top of HTTP or HTTPS. We'll have a brief overview of what that is in a minute. But the main reason for this is so much of the World Wide Web relies on HTTP as a protocol that by relying or building your API on top of HTTP, you can make use of all that existing infrastructure. A lot of firewalls are built to prevent access to sort of like random ports on your server, and have a lot of support already built in for allowing access to HTTP services. So by building these RESTful APIs on top of HTTP, they get to reuse a lot of existing infrastructure. And we'll talk about a good example of that in a minute. First, though, as a quick detour to talk about interchange formats, or data interchange formats. So as I mentioned, SOAP uses XML primarily. RESTful APIs use JSON. So XML is the extensible markup language. It has a particular schema. It looks closer to HTML. It has tags, and tags have values and attributes, although this example doesn't have attributes in it. JSON instead is the JavaScript object notation. So if you've ever written objects or written JavaScript and had to code objects, then you've already used essentially what what is JSON, where you can think of it really in terms of a set of keys and values. The keys and values can really be arbitrary. Keys are strings and values really are anything, although you can have, I think you can have integers as strings as well. But JSON is the most common data interchange format, I think, that you'll really come across in the vast majority of APIs, unless it's some old legacy API or using something older. Now that said, there are other languages or other interchange formats. One new example that's gaining traction is called GraphQL, which is a query language for your API. GitHub has a GraphQL interface or a GraphQL-based API. I think Facebook's Graph API maybe has a GraphQL one, so does GitLab. A number of things are starting to use the GraphQL language as well. You don't have to worry about that. Feel free to use whatever you want, but the most that you'll see, I think, or the most common you'll see are going to be JSON-based RESTful APIs. So some quick background on HTTP, just so you get some familiarity if you need to sort of build some access or use some API directly. I'll talk about what that means in a minute. HTTP is the Hypertext Transfer Protocol. If you look at the vast majority of web pages that you visit via your browser, it's this part. So HTTPS is the secure version of HTTP that uses the secure socket layer to add encryption on top of HTTP. And APIs can use HTTP or HTTPS. Most of the programmatic facilities you'll use will be able to handle either one for you. HTTP has been around for a long time. It was initially introduced in the RFC 1945 back in 1991. This is Tim Berners-Lee and a number of other people in the origins of the World Wide Web. And it has grown and evolved over the years. So 1945, RFC 1945 was officially adopted in 96. There was a 1.1 follow-on, which allowed for additional performance enhancements. In 99, there's a version 2 that's been around for about 6 years now. Mostly everything that you'll have to deal with will be sort of agnostic to the underlying version. The main ways that you interact with a server that provides, or an API that provides the HTTP protocol is through these methods. So head, put, delete, post, and get. By far the most common is going to be the HTTP GET request. So basically any sort of web browsing you do works as a bunch of GET requests to a web server that asks for the URL. So you send a GET request to the server with the URL that you're looking for, and then the server responds with an HTTP status code that tells you whether you get that content back or there's some error. So that's where you see like 404 error not found or 500 internal server error. These kinds of things are generally HTTP responses to these methods. And when you need to send data to an HTTP server, so you're posting or putting in a post on Twitter or Facebook or uploading an image or something, these are generally done with HTTP post requests. There is some addition for put and head, which we won't really talk about, though if you're interested, by all means reach out and we can discuss. If you need to access a raw HTTP API, Python has a really good library for this called the requests library. And in fact, the very first page or the documentation for the request library has an example about using the HTTP GET command and the request API to access the GitHub API. So you access or send a GET request to api.github.com for some user. You authenticate using basic HTTP authentication. You get some status code. You can read headers. You can get the text of that content, and you can automatically parse it into usable JSON, which in Python gives you back a nice dictionary with keys and values that you can then work on. So that's sort of the way you interact with APIs in a very raw kind of form. In order to work with APIs, though, generally systems or services are using these APIs to enforce access control and rate limits. Many APIs you have to register for, though that registration can be free or is often free. But you have to register in order to get developer keys. So then the keys that you get are generally associated with some level of access and rate limits. So if you're Twitter, for instance, you can apply to Twitter to get access to a set of developer keys, and then those keys have some limit on the number of requests that they can make over a 15-minute period. I forget what exactly the numbers are, but it's something like you can make 500 requests of getting a particular tweet or getting tweets in a 15-minute block. And then after 15 minutes, it resets. This is the way that the platform is able to control rate limits. You can pay additional money to get higher rate limits or more access, these kinds of things. So this is an example on the left. This is an example from the New York Times developer API, where you create an account, register your application, then your application gets a set of keys, and then you can access your API with those keys. I'll note, I don't have it in the slides, but there are generally two types of keys that you may have to use. They're your user keys, and there are also consumer and access keys. So sometimes you'll have actually 4 different keys that you have to use that'll differentiate the access for your application and for a particular user. Fortunately, though, you don't have to rely on raw HTTP and for API access the vast majority of the time. For many popular services, there are already API wrappers that you can use in order to access those APIs. Some of these are actually provided by the platform, others are open source. For instance, with Twitter's API, they actually have a number of official tools and libraries based or written for different languages. So they have the Search Tweets Python package as a package for Python. They have a Ruby one. There are pieces for JavaScript. There's the Tweepy library, which is popular. If you're using Java, there's Twitter for J. All of these have API authentication and access already built in for you. Reddit has its own API that you can use. It's actually very easy to use. Python has a wrapper for it called praw. It's very straightforward, but also handles authentication for you. Facebook has a lot of different APIs that you can access. It has one for JavaScript and for many other languages as well. The New York Times, which is a good place if you want to do like news mining, has the NY Times package that you can use. As for all of these, as long as you are registering and creating accounts and getting access keys, all of these will be relatively straightforward to use. For Module 1, for the Module 1 assignment, I ask you to collect data from some API and then do some analytics on it. It doesn't have to be a lot of data, but just demonstrate that you can use the API to collect data of some form. If you want, there are a lot of public APIs available. This GitHub repo has a pretty significant list that you can play with. This is a good place to start for your Module 1 assignment. So that's just a very brief overview of APIs. We've talked about SOAP and RESTful APIs as types of web services. We talked about XML, JSON as the 2 primary data interchange formats. If you have never seen APIs before, you have at least some very lightweight background that'll introduce you enough so you can get started on Module 1. Of course, if you have questions about any of this, post in the discussion forum for Module 1.